100,000 installs in the world, and we have about 2,000 employees. We're working with the industry leaders. You can see a lot of name dropping here, and we are mainly focusing about polymer printing. We hold a wide variety of technologies to support the different polymers that are in the field. And we're also working with the top software companies in order to make our printing much more suitable for the industry users. Talking about a little bit about the products that we have. So we have 5 different main technologies. Each and one of them have different levels of scalability, I would say, or professionalism. Some platforms are smaller, some are bigger. I'm not going to go into the details of that, but just to give you a whole perspective of the offering that we have. And if I'm going to talk about more about the medical, so this was just an intro. So our vision in the medical department is to become the choice for personalization in 3D printing solution, be the first choice for the customers. And that is what we're focusing on. And just to give you a little glance about the medical team at Stratasys, so we've done quite a significant way in a short amount of time. So Stratasys is an old company in the industry, over 30 years of 3D printing experience, but the medical department is rather young within Stratasys. We had medical customers, but we didn't have a department aimed for those customers. So we were created, or inception of the medical department was around 2016. And you can see that we've done quite a lot ever since in a very short amount of time. And I can say that all of the processes that we've done throughout the past few years was with the industry and according to the industry's voice. We listen to our customer, we're doing processes to improve their usage, and a lot of it comes from point of care. So basically where we want to be is we want to be in a better place, all of us, obviously. We want to improve the patient care. We want to reduce the time in the OR. We want to reduce the risks and complication of the surgeries. And supporting that, we would like also to help bring medical devices faster to the field. And the way we do it is using our technology and aiming at the trends that we see in the industry. If we talk about the whole medical industry or the point of care industry, we see that there's a few major trends that are changing or occurring at the moment in the industry. The first one is the digitalization on imaging technology, which enables more personalized therapies. We see that there is a lot more personalized treatment in the medical field, and obviously additive manufacturing has a great benefit to personalized solution. We see what we call smart patients, or I would say people who are looking at the solutions that the hospital can provide for them, and according to that, they choose where to go. So hospitals that offer more solutions or more technology, I would call it. It doesn't have to be additive manufacturing, but more variety of solutions will bring in more patients. Another thing that we see as a big and impactful trend is bringing the technology in-house. A lot of hospitals used to work in collaboration with service providers, with service bureaus, with other companies that would print the models for them or create models for them. We see a lot of change in that field, which hospitals want to hold everything inside. So bring the technology in, bring the knowledge on how to create these models, and have control, full control of the whole process. Another thing that we see, and we discussed it briefly before the webinar started, is the evolving in regulatory guidelines. The regulatory guidelines were unclear. I can say that the regulatory bodies were kind of missing the point where the technology entered the hospital, and now they're starting to ramp up and to keep up the pace and starting to see that it is already there and giving some I would say not strictly strict protocols, but they are starting to give attention to that and give guidelines, and that is something that is influencing the whole industry. Reimbursement is also something that is in process, but still a long way from happening, but is also something that is currently in the process, and it will definitely have a major impact on additive manufacturing within hospitals. And the last thing that we see in the medical trend is the bioinks that are really advancing. We are not in that field currently, but we do see a big trend in this area. We do see that hospitals also have a lot of, I would say, challenges to overcome and to adopt 3D printing in their hospitals. The first one is the lack of reimbursement, which, as I mentioned before, it's going to have a major influence on the adoption of 3D printing once it happens, if it happens. The medical staff is limited with time. Doctors do not have the time to go over the design of the model, iterate it, go over the model over and over again until it satisfies their requirements. And the technology is still very cumbersome. It takes a lot of time to create models. It takes a lot of experience and knowledge and know-how to create valuable and quality models. There is no comprehensive solution, meaning that there is no one-stop shop. If you want to create a 3D printed model in-house, you have to go through a few softwares and a few processes in order to have this model. The high cost is also a big influence on adopting that technology. And like I mentioned before, the evolving of the regulatory guidelines is also something that is a hurdle. In order to improve patient care, we Stratasys are focusing on major three topics, I would say. So the main one is preoperative planning, training, and simulation, and research in order to improve patient care. In order to answer these requirements, we offer an advanced materials, technology, proven accuracy and repeatable results for our prints, and patient-specific solution. We give a lot of clinical data and scientific data to our products to show that the results match the human biomechanical behavior in different aspects. We've done this case studies and lab reports with the industry leaders in order to prove that. And we also have a lot of biomechanical, biocompatible material and sterilizable material. So the benefits of patient-specific solutions are pretty obvious to everyone, but I will go over them anyway, just to make them more clear. So anatomical models are improving the way that surgeons can plan a surgery in advance. They can actually hold the model of the patient, examine which path will be the best for them to operate on, and then they can go into the OR with more confidence. Having a surgical guide is also something that reduces the time in the OR, reduces the complications, and allows better accuracy in performing the operation. And having a surgical kit is basically mixing these two, having both the anatomical model for training before entering the OR and the surgical guide as well. We did map out the process of creating a model, and we've noticed that the part of the segmentation is the labor-intensive one. If you can see the workflow, if you want to create a 3D printed model out of a patient scan, the process is to, first of all, get a scan, either from a CT or an MRI, and then you need to convert this scan into a printable file, which is the segmentation part. This is the big hurdle for most of the hospitals. There's a lot of experience into this process. There's a lot of labor into this process, and this is the main barrier. And then you have to get the actual print. So a printer, owning a printer and managing a printer is also a hurdle in the process. We've just yesterday announced that we have invested in a company which is called Axial in order to have a service that will answer this whole part that is very cumbersome for the customers. So we have a service to do the segmentation as a service, and also get the parts printed for you and shipped over to the hospital to reduce all this labor-intensive process from the patient care providers and surgeons who don't have time to go over these processes. If I'll drill down into the solutions that we offer, so we offer two main products that are aimed specifically for the medical industry. We also have a lot of products that are not specifically for the medical industry, but they can be used for it. The first one is the J5 MediJet, which is a small footprint, high throughput material, which can print biocompatible materials and full color materials. And the second one is the J850 digital anatomy printer, which can print biomechanically accurate models with lots of material mixture, full color, transparencies, different softness levels, and they all backed up with the clinical data that I've said about the lab reports that show that the models behave like the biomechanical actual organs. In terms of regulatory aspects, we have FDA cleared diagnostic workflow. You can check our website. I'm not going to talk into the details of every software and materials that we've validated, but we have a lot of validation processes with lots of the software that are used in the field. And we also have a wide variety of biocompatible materials. Some cases that I would like to share with you about how we are using our materials, or how the industry is using our materials. So first of all, is the Jacobs Institute, which is using our models to simulate intravascular operation. So they print vascular models, and they are using their devices to check them under our materials. They have definitely been working to advance the medical industry and to introduce new medical devices and test them within their facility using the technology that we have instead of using cadavers or animals. Another case is from the Seattle Children's Hospital, where they have they had a case of a baby which had a trachea deformity, and this baby had to breathe through a ventilation system until they had the model that was resembling the trachea that they can operate on pre-hand or pre-op to the actual surgery to get confidence that the surgery will work. And only after they did a few iterations on the printed model, the surgeons got the confidence to actually go into the surgery and perform the operation. Another case is from Nicklaus Children's Hospital, where they used the model to pre-plan tumor removal from Roy, which is the kid that you see here. It was in a very complicated place within his brain, and the model really helped the surgeons know how to approach the tumor without damaging Roy's brain, and also how to not damage his visual appearance while doing the operation. A key thing that we need to ask ourselves in case we are interested in opening a 3D printing lab within our hospital is a few questions, and only after you know exactly what you want to get out of it, then you can actually go and start picking the equipment and going and actually buying or purchasing the devices. So first of all is, what are the main application you're targeting? Is it just one? Is it a few applications? The second thing is the anticipated printing volume. If you're only doing a case per month, then a certain technology will help. And if you're doing 10 cases a month, then you will need a whole different technology. The allocated budget that you have for it will also determine the printer that you can afford. The staffing is a major issue. If you want to bring the technology in-house, you have to think about the personnel who are going to create the models and to operate the printer. And last but not least is the facility. If you have the flow space, if you have a dedicated room for the printer, you cannot just put it near the kitchen area or the coffee area. You have to have a designated place, and that will also be defining which printer is applicable or is suitable for you. What I would like to say here is that after answering all the questions from the previous slides, Stratasys has a solution for each and every one of the stages. We have a variety of printers and solutions that will enable you to be at any level that you would choose. If you want to be at the entry level, which is low volume and simple models, if you want to be an advanced user, which is very complex models and high volume of printing, we can find and fit the perfect solution for your hospital and to escort you in your journey into a successful point of care printing. To summarize it, what we see in the future is, again, a lot more personalized therapy options. We see a growing demand by point of care, and we see a big shift of bringing printing in-house instead of going to service and bureaus. We see an increase in regulatory bodies, which means that you have to give attention to where it's going and what is the direction they're aiming for. And as a side thought, there is also a lot of advancement in bioprinting, which is not our field of expertise, but we do see a lot of things happening there. Thank you all for listening to me. If you have any questions.
Yes, we have a couple from the audience, maybe quick or hopefully relevant to this. One is, do you guys incorporate augmented or virtual reality in any part of your current workflow?
So it's not incorporated, but it's visible. We have a few case studies that were collaborating with AR and our models, but it's not something that we have as a built-in. It's not just plug and play. You have to do a little bit of a mix and match, I would call it, between our models and the virtual reality. And
that's a third-party software. It's not you guys.
Correct. It's not. We don't have any VR AR equipment in-house. No.
Okay. Okay. This is a practical question. I'm not sure exactly if it's relevant, but it says, how do you find skilled employee with 3D printers?
Wow. That's
I don't know where the person is from. So for the United States, at least, it's pretty hard.
It is. I have a good answer for that, but it's not good in the essence of it.
Okay.
Unfortunately, there are a few companies that are laid off a lot of workers from the 3D printing industry. I don't want to name the company, but you probably all know it. So that's a good place to start with. But we also find a lot of I would say they're not professionally trained, but we have a lot of people who are, I would say, 3D printing as a hobby.
Yeah.
And they really, really know their way. So that's how we find capable workers.
So it's not really a very formalized educational process right now. It's basically people doing their own.
I think there's only a handful of actually I don't know if it's projects or curriculums that teach 3D printing. There are a few, but they're not so many. And also, if there are, usually they're not in the medical arena. So that's even harder to find.
Right. Yeah, I'm really surprised to hear that point of care actually is more than service bureau in terms of I guess you're counting either for material sales or printer sales to see the trend. I always like whenever Stratasys presents, there's always a trend report. So that's